Download this code from codegive.com, link in the description below. Benchmark.net is a powerful and flexible library for benchmarking .NET applications. It allows developers to create precise performance tests of their code, helping to identify bottlenecks and optimize performance. In this tutorial, we will cover the steps to set up benchmark.net to benchmark a .NET application, including a code example. Step 1. Setting up your project. 1. Create a new .NET project. You can create a new console application using the .NET CLI. Open a terminal and run the following command. Bash .NET new console and benchmark example. cd benchmark example. 2. Add benchmark.net package. Install the benchmark.net nuget package by running the following command. Bash .NET add package benchmark.net. Step 2. Writing benchmark code. Once you have set up your project, you can write the benchmarking code. Below is an example of how to use benchmark.net to benchmark a simple method that calculates the sum of an integer array. Sharp. Using benchmark.net attributes. Using benchmark.net running. Using system namespace benchmark example. Public class benchmarketists. Private int numbers. / setup method to initialize the data before each benchmark. Global setup. Public void setup. Numbers equals new int 1000. Random rand equals new random. 4. Int I equals 0, I numbers dot length, I plus. Numbers I equals rand dot next, 1, 100. / benchmarking method for calculating the sum using a loop. Benchmark. Public int sum using loop. Int sum equals 0. 4. Int I equals 0, I numbers dot length, I plus. Sum plus equals numbers I. Return sum. / benchmarking method for calculating the sum using linq. Benchmark. Public int sum using linq. Return numbers dot sum. Public static void main, string args. Var summary equals benchmark runner dot run benchmarketists. Step 3, explanation of the code. 1. Namespaces. Benchmark.net attributes contains attributes used to mark methods for benchmarking. Benchmark.net running contains the benchmark runner class to execute benchmarks. 2. Benchmarketists class. The class contains two methods that we want to benchmark, some using loop and some using linq. 3. Global setup. The global setup attribute indicates that the setup method should run before any benchmarks. This method initializes the array of integers with random values. 4. Benchmark methods. Each method annotated with the benchmark attribute will be executed by benchmark.net, and performance metrics will be collected. 5. Main method. The main method is the entry point of the program. It calls benchmark runner.run benchmarketists to execute the benchmarks. Step 4. Running the benchmark. To run the benchmark, use the following command in the terminal. Bash .NET run C release. Make sure to run it in the release configuration, as benchmarks should not be run in debug mode due to optimizations and additional overhead. Step 5. Analyzing results. After running the benchmark, you will see output similar to the following. Method mean error stddev --. Sum using loop 1.234 milliseconds 0.012 milliseconds 0.011 milliseconds. Sum using linq 1.567 milliseconds 0.015 milliseconds 0.014 milliseconds. Mean, the average time taken to execute the method. Error, the margin of error for the mean. std_dev, the standard deviation of the measurements. Conclusion. Benchmark.net makes it easy to set up and execute benchmarks in a .NET application. By following the steps outlined in this tutorial, you can benchmark your code, gain insights into its performance, and make informed decisions about optimizations. Feel free to extend the example by adding more methods to benchmark and experimenting with different algorithms. Benchmark.net is a powerful .NET library designed specifically for benchmarking your code. It allows you to measure the performance of your applications with great precision. In this tutorial, we will go through the steps to set up benchmark.net and create a simple benchmark for a .NET application. Step 1. Setting up your project. 1. Create a new .NET project *. Open a terminal and create a new console application. Bash. .NET New Console and Benchmark Example. cd Benchmark Example. 2. Add benchmark.net package *. Add the benchmark.net nuget package to your project. Bash. .NET add package benchmark.net. Step 2. Writing the benchmark code. Now that we have our project set up, let's create a benchmark. We will create a simple benchmark that measures the performance of string concatenation using different methods. 1. Create a benchmark class *. Create a new class named string benchmarks.cs in your project directory. #. Using benchmark.net attributes. Using benchmark.net running. Public class string benchmarks. Private const string word1 equals hello. Private const string word2 equals world. Benchmark. Public string concat equals string.concat, word1, word2. Benchmark. Public string interpolation equals $word1 word2. Benchmark. Public string builder. var sb equals new system.text.string builder. sb append, word1. sb append, word2. Return sb to string. 2. Create a main method to run the benchmark *. Open the program.cs file and modify it to run the benchmark. #. Using system. Namespace benchmark example. Class program. Static void main, string args. var summary equals benchmark runner.run string benchmarks. console.read summary. Step 3, running the benchmark. 1. Run the application *. Open a terminal and run your application. Bash. .NET Run C release. Make sure you run it in release mode for accurate benchmarking results. Benchmark.net automatically handles various configurations to ensure reliable measurements. Step 4, understanding the output. After you run the benchmark, you will see output similar to this. Method mean error std_dev gen0 gen1 gen2 allocated. Dash 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 dash. String concat 0.01234 us 0.000123 us 0.000456 us 0.0006 0.000000.00002.50 kb. String interpolation 0.01567 us 0.000234 us 0.000567 us 0.0006 0.000000.00002.50 kb. String builder 0.01890 us 0.000345 us 0.000678 us 0.0006 0.000000.00002.50 kb. Mean, the average time taken for each method in microseconds. Error, the margin of error of the mean. STDDEV, the standard deviation of the mean. Gen 0, Gen 1, Gen 2, memory allocation details. Allocated, total memory allocated during the benchmark. Step 5, analyzing results. Compare the means of each method to determine which string concatenation method performs best. Use the memory allocation details to analyze which method is more efficient in terms of memory usage. Conclusion. Benchmark.net is a robust tool for performance testing in .NET applications. By following the steps outlined in this tutorial, you can easily set up benchmarks for your own code and analyze performance characteristics. Benchmarking helps in selecting the most efficient algorithms and data structures for your applications, ultimately leading to better performance. Additional considerations. Ensure that your benchmarks are isolated and that no external factors influence the results, example running benchmarks on a dedicated machine. Benchmark.net has many advanced features, such as custom configurations, exporting results, and more. Explore the official documentation, https://benchmarkdotnet.org, for more in-depth information.